A lot of products on the market think that talking to the cloud and the file world by taking snapshots of a file system without any useful metadata is using object storage to store files in the cloud, and that's just not the case. What you're storing is snapshots and nothing really useful because you can't really get to the data through the object store and there's no metadata. So the way we handle it is we take a file server, and in our case our primary target platforms are Microsoft and NetApp. And what we do is we treat this as a cache. And what we do is we say, hey, size this to what you want because it's from your familiar world. But when we store it in here, we'll actually store it as an object. We'll pre-process and extract metadata and insert it without you having to do anything. So we'll take what it knows about in the file system, we'll put it in it. We'll potentially run it through an additional pre-processor that will actually extract more data. And so what we do is we put the object in, but we put it into our namespace, all while being able to access it through the filer as well. So now you get best of both worlds. You can put it in through file, and you can read through object, and you get the metadata capabilities that you want out of object that you can't leverage in the file system. And now you actually have a place on which you can access directly through object storage, and you can use your file system as an interface to legacy applications to help you meet the needs of your file system. And that's how we handle it right now. And the only other components that we're adding to our file strategy is that Microsoft has done a nice job taking WebDAV further down the road now, and we will have a WebDAV server that we will actually have native to our interface, to our system. And the last file system we actually talked to is Hadoop. And what we've done is we've implemented a native HDFS interface that actually talks directly to us, so that your MapReduce jobs can just read directly from the object storage system. And because the object storage system is a massively scalable web server, you can read from it in parallel. So that means that if you have elasticity in your Hadoop MapReduce jobs and you spread them over some VM infrastructure, we're capable of handling however n many connections you need to expand that, and you no longer have to do any ETLs. Your data resides here, and you can take it out and process it for Hadoop. You can insert new metadata back into that data as you do that processing. And now what you can do is rather just search and collect up the set of stuff you want to look at and process through Hadoop. You send that to a Hadoop, and it just reads directly from the cluster. And so what you have is a very small Hadoop file system out here for scratch space. So now you can really leverage an OpenStack infrastructure or otherwise to scale up and down your jobs without having to have a storage infrastructure in place. One of the things I want to describe is, we truly treat this as a cache. So what you would say is, most of my files are only active for 30 days, then what you would do is size this to be the active 30-day file size. And what will happen is that as you store your objects in here and they age, we'll actually physically move those objects here and provide you an entry into the file system so you can still get to your files if it exists there. Files that are stored here, and basically any file type that you store here, there are rules, and it's much like an HSM system, and it'll cache that object there until that rule is fired, and then it will either move the object, copy the object, do whatever rules you choose to apply, and put it into the object store and its namespace. So now you can get to it through the object store, and that can be any file type. That can be VMs. VMs are a great thing. Put a whole bunch of those in here. They fit really well. This has the capability to load in parallel to the object store, so you can get good throughput from it. And you can use store any type of file through the system that you would normally file. It's just a filer to you. You manage it just like your filer. It hooks into your Active Directory. We don't get in any of the way of that. We sit under the covers. We move all your files, databases. We don't actually move the database. Databases are really particularly for filers. They make sense. We can back them up. We can back up VMs. We can put in your Word documents, your Excel spreadsheets, your images, your videos, whatever you have out here will work in here, and you'll be able to access them directly here. The advantage of doing it the way we do here, where we actually move the data after it's been stored on the filer based on whatever rules, is that the behavior of the server itself doesn't change a bit. It doesn't change in the data center, the guy managing it, the application using it. They see no difference whatsoever. It just provides a means to provide you a file system interface to anything that you want to use. It could be a legacy app, or you could use it as a new one. It's really up to you. But it gives you a way to use your infrastructure just like you used it, and yet get the objects into, get the files into an object store and be able to manage them as individual objects that you can do a lot of other operations on as part of the object store. And there's no need to mess with file format. You don't have to know anything about the applications out here storing file. It just stores whatever you store in here. It'll put in the object store, and it will give it a name, and it'll give it metadata, and now we can start leveraging it as an object.